For homework 4, part A2, we're going to use the equations we derived earlier in order to numerically solve our equation. We have our initial flow rate, what it's increased to, the drainage hole area, and the cross-sectional areas. We have NumPy, SciPy, integrate, and Plotly already imported. And we have our givens as well as the gravitational constant. The next thing we'll need to do is get our initial height of the tank, which will be equal to our initial flow rate in squared divided by the drainage hole area squared times 2 times g. All right, next thing we need to do is define our function dHdt as a function of time height. And from this, we'll get our Q1, our Q2, and our Q3, which will be equal to AD times 2 times G times H, square root of that, of course. And then we'll return our changing height. So we'll have our Qn minus Q1 divided by the cross-sectional area of 1. Then we'll have our what's going into the other tank. So Q1 minus Q2 divided by the cross-sectional area of the second tank. And then we'll have what's going into the third tank. So Q2 minus what's going out, Q3, divided by the cross-sectional area of the third tank. All right. Don't know if this needs to be in brackets or not, but it's fine for now. So the next thing we'll need to do is get or solve for this function. So our results is SciPy dot integrate solve IVP. We want to solve our function dHdt. The next thing we need is our the range on which this will work. So does this need to be, I cannot remember, but we'll go here for now. We'll go 0 to t end. Next is our initial value, so H0. Our dense output equals true. And that should be good, or I don't remember if we need our method. Add a U. Sure. Okay. We'll ignore this for now. Does this work? Yep. Okay, so then, because we did our dense output equal true, we'll have to do our t-plot. So we'll get equally spaced points and p dot lens space up to from 0 to t end, and we'll do 1,000 points. So the next thing we'll do is we will get our values for each point. So our H1, H2, and H3 will be equal to res.solve of our t-plot. Now, do we have something that comes up for these? All right, that looks good. So now we just need to plot these out. So it equals subplots and fig dot add scatter Our x will be equal to t plot. Our y is equal to h1. Our mode is lines, and what else would we need here? And our name is h1. So does that give us kind of what we're looking for here? Yeah. And then we'll just add h2 and h3. As you can see, after our simulation is over, our system comes to a steady state at around 11.4 and 10.9 here. And yeah, so that